Hello, thank you for joining today's webinar. Enable ROI within 1 year of adopting DevOps practices. Our speaker today is Dwayne Wente, Advisory IMS Software Consultant at BMC. Dwayne is an advisory IMS software consultant at BMC Software who has helped many large BMC customers over the last 23 years understand, implement, and exploit BMC IMS solutions. He has worked with accounts like Bank of America, Federal Express, TSYS, Verizon, and other clients on IMS discovery, disaster recovery, database performance, and tuning engagements. Prior to moving to the software consulting organization, Dwayne was involved in many successful IMS product development projects. And now I'd like to hand the floor over to Dwayne. Dwayne, you now have the floor.
Welcome to this IMS webinar. Today I'm going to be introducing you to our first introduction into DevOps in the IMS space. The products that I will be talking about is change management for IMS systems definition dynamically, and also for IMS application control blocks, which would be more from a DBA application development perspective. Well, the reason why BMC is moving our portfolio in the DevOps direction is because over the last 16 years, BMC has done an independent study or survey of mainframe users. And during the last several years, DevOps has had heightened awareness, as you can see by the statistics. 78% cite that the ability to adapt to demands and update mainframe applications more frequently is very useful. Over 50% indicated that they are now using DevOps in the mainframe space, and 77% indicated that their organizations have DevOps practices in place, and this number's up considerably in the last 3 years from 33%. 74%, which is the interesting metric, indicate that DevOps implementations are seeing return on investment in 1 year or less. On the flip side, they're saying that they're getting greater stability, improved application quality, and security is also being improved as a key for DevOps on the mainframe. So what is DevOps actually? Is it a software product? Is it a process? Well, it is a process. And it has its beginnings in Agile development, and it was a means to bridge the gap between the participants in a project. From a development perspective, it was to bridge the gap between development and quality assurance to be able to bring efficient and effective software into the main stream development process, and to bridge inequalities from a QA perspective. It also wanted to bridge together the operations area so that when the application was delivered, that the build, validation, deployment, and delivery and support of the product was integrated into the process. So it was initially trying to bridge this gap between those organizations so that they could communicate effectively to shorten the timeline for delivery of applications. Before DevOps came into the picture, everybody was using kind of a waterfall development, and that really had independent goals and objectives by each group. And that really provided a natural love-hate relationship because sometimes those were conflicting objectives and goals. DevOps, or same team approach, really has a number of great objectives. Improves deployment frequency, lowers the failure rate of new releases, achieves faster time to market, shortens the lead time between fixes, and improves mean time to recovery. So those are really good goals and objectives to move our development processes into the DevOps world. What do we mean by DevOps? Well, it is really terminology, and it really incorporates continuous integration, which is integrating new code into the mainstream code process, doing initial testing, and then moving directly into the delivery process, whereby additional testing and automation is included in the process, and then for continuous delivery. And all at the same time, we're adding the appropriate automation to the process to remove human access or ability to interact with those applications. We want to remove that as much as possible with automation. When we look at the DevOps process from collaboration to run, you can see there's an exorbitant number of program products available in the marketplace. At BMC, here we use application lifecycle management called Jira. We use knowledge sharing with Confluence and Microsoft Teams. In our source code management and the build process, we use GitHub, we use ISPW, and of course, what I'll be talking about today is our continuous integration. We have used the Jenkins plugin. And then of course, during the build process, and we're using Maven. So there's a wealth of products that you can integrate, and it's really a partnership. It isn't just one product. And when you start down the DevOps process like we did, it's not one day you're not using DevOps and the next day you're fully DevOps implemented. It's a progression and a natural process. You start with collaboration, then you start doing the build process, and then you work into deployment and testing and running. In January of this year, we released AMI Change Manager for IMS TM. And that particular product helps us to dynamically modify IMS control blocks from a systems perspective. This is a rename of our Delta Plus product, and Delta Plus is the technology under the covers that's being used. Now, we integrated DevOps into the process by building a Jenkins plugin for this enabling. So this is our first DevOps IMS development aspect, and you can see by the graphic at the right, basically what happens here is a development team has asked us to add an IMS transaction to the IMS system. We're using, in this case, GitHub for a source code manager. You may be using ISPW or another product for that purpose. And the build process is where we have the Jenkins plugin, and the build process is used to build our Delta list that will be executed on the mainframe to actually implement those changes that are requested from a system perspective. As I said, for our CI workflow, we had to start somewhere. So we started with using Jenkins because that seemed to fit our requirements and is used for automation. You can see on the right is the Jenkins product and the workflow that we developed for our Delta list processing. All Delta list actions can be done through the Jenkins plugin. You can create a Delta list, add or revise a transaction, or add or revise a database. You can edit that Delta list before it goes into production to validate it against your IMS control region to make sure that that Delta list is doing what you expect it to do. And then, of course, when you're ready, do the execution. These are all individual plugins through that Jenkins plugin process. And then we, of course, use the ZOSMF REST API to submit the jobs on the mainframe, because the actual technology to make the change on your IMS systems is actually Delta Plus that's running there. All Delta list elements are actually supported. We can add application macros, transaction macros, database macros, root code, terminal, LTerm, and subpool macros are all supported through the Delta list creation. The Jenkins plugin is implemented as build steps, and you can see in the build list pull down, what you would select here is the BMC DevOps for Delta Plus plugin, which would be there after you do the installation. So what is the Jenkins plugin really used for? Well, basically it's used to build the Delta list, and you decide what action you want to do. When you pick the action, in this case, it's an action to add a transaction. You get all the options then that are required to implement that through a Delta list process execution on the mainframe. And where do you want that action to occur? Which mainframe connection options do you want to have set up to implement those changes on that particular connection? What are the BMC Change Manager for IMS TM options? And those would be specific to the action that you've actually selected. And then, of course, we generate the job information, which is the execution of the batch job that would be run on the mainframe to actually implement those changes. Once you've executed that Delta list on the mainframe, you can go back into the Jenkins workspace, and based upon the job that was executed and the job number, you can select that, and then of course you can see the results of that output of that Delta list in that from the JIS log in the Jenkins workplace. And you can see by the highlighted area that the build actually completed successfully. So how do you actually implement the Jenkins plugin? Well, it's very, very easy. You go into the Jenkins console and go to the plugin manager, click on the advanced tab, and you would upload then what we distribute, which is the DevOps 4 DLP.hpi file. Click upload, and that's going to install the plugin. To verify that the actual installation occurred, you would go to the Jenkins plugin manager, install to verify that the plugin installation had actually occurred. Okay, let's talk about the other side of the equation, change management equation. That is BMC AMI Change Manager for IMS. This is on the database side and would be used more frequently by IMS DBAs and IMS application programmers. AMI Change Manager for IMS uses our UXF GUI interface, which is HTML5 underneath. All of our GUIs are moving in this direction. This happens to be the first one. It provides activation of DBD changes and PSB changes, and also provides backup facilities such that if you don't get the results that you want to have implemented, you can back out to prior to the when this particular project was used for implementation. It supports both the IMS Gen process and the IMS catalog and managed ACBs as IMS is moving in this direction. This will also provide a mechanism for both experienced DBAs as well as universal DBAs coming into the IMS space to be able to work effectively. The key in the heart to the product is actually the impact analysis engine, and this does an analysis of the changes that you've specified for those control blocks. Once that analysis has been done, it determines whether you have accurately specified the options for the type of change that you're trying to make, and it determines what needs to be executed to actually implement those changes. On the other side of the product, we provide some supporting applications for making DBD and PSB changes through projects. One of those is actually an interactive generation execution of IMS type 2 commands. And I will show you how that's done a little bit later, because I think that particular functionality is very, very easy to use and will help both DBAs and applications people be able to issue those IMS type 2 commands correctly. Another application tool that we provide in the app section is an IMS buffer pool tuning tool. And this allows you to dynamically alter any of the IMS buffers through the GUI. Our design objectives for BMC AMI Change Manager was these. We wanted to simplify the IMS maintenance process for any DBA that needs to work in this space, whether he's experienced or non-experienced. We wanted to ease the use of supporting IMS from an IMS database as well as an IMS PSB perspective. We wanted to reduce the risk of database change errors that might cause an application failure. And we also wanted to reduce skills gap for universal DBAs that are newly coming into the IMS space and have to manage IMS databases and PSBs. As I indicated earlier, we support both the traditional gen process, which is experienced DBAs have been using for decades. And we also wanted to ease the migration to the IMS catalog. Most DBAs who have been working in this space a long time don't have a lot of experience using the IMS catalog and managed ACBs, and that is the stated direction that IBM has indicated that they're moving to. And we want to provide scripted workflows for those universal DBAs so that they know exactly what needs to be changed as a result of making changes to one database, one PSB, or a number of databases or PSBs. And of course, provide a GUI interface that's a modern interface that uses the UXF GUI interface that we've now implemented, not only in the Change Manager products, but also for new GUIs that are coming up, which is a replacement for our MaxM Database Advisor. We hope that this product will encourage new DBAs to be successful in the IMS space. The experienced IMS DBAs, they're very comfortable using the IMS gen process. They've been using it for decades. They're also not very comfortable using the IMS catalog and managed ACBs. And they're experienced using ISPF interface and green screen and understanding JCO and batch jobs. On the other hand, new DBAs that are coming in, many of my customers that I'm working with, they're considered universal DBAs. They have to support both relational databases as well as IMS. They're comfortable talking in the about DDL and using DDL. They're used to using an IMS catalog to support database activities because that's what's used in DB2. They're experienced using GUIs, but they're less experienced creating and running JCL. So this product will blend those two experience levels and kind of reduce that skills gap between the two individuals. Everything that is done in Change Manager for IMS to make changes to DBD control blocks and also PSB control blocks are done via projects. And the definition of projects is your definition. So if an application area is making a significant change that requires changes to multiple DBDs and multiple PSBs, those can all be housed in one project. You make the changes to those DBDs and we check the changes for syntax errors. We also check for logical errors during the analysis process, which is really the heart of this particular product, and then generate a script which includes all the JCL that's required to make those changes correctly and to incorporate in that a remarks or README file that contains remarks about what's going to be changed with this particular project, who's making the change, the date of the change, and then generally what's going to be changed as a result of this particular project. And then the GUI also provides the capability to manage projects. Maybe you're partway through making the changes to the databases and also the programs, or the PSBs, and the applications area decides that they need to add some additional changes, so you can incorporate and add those changes into a particular project, rerun an analysis, get the changes that would be required to implement, and manage the projects also from a delete perspective. In other words, if you no longer have a requirement to maintain the project in the repositories for Change Manager for IMS, then we provide the ability to delete that project out. As I said, and I want to reiterate, we want to reduce the risk of making database and PSB changes to avoid application outages by doing effective analysis and doing impact analysis of what those changes need to have done in order to implement them correctly. The generated jobs are a step-by-step process in the implementation process, and at the same time we build a backup job that will automatically back out the requested changes in the project back to before the project was initiated. What's key here is, as I said, we want to bridge this skills gap between existing IMS DBAs and those universal DBAs that are coming into the industry. And we do that by providing both a gen format for the DBD macros that has remarks in it that says these are the changes that you made. This is for the experienced DBA because this is the format that the experienced DBA understands. The DDL format, on the other hand, is for either the applications programmer that's maybe trying to write a distributed application to go at an IMS database, or it's as a learning tool so that both the experienced DBA as well as the universal DBA have a common language for discussion purposes so that they can avoid errors or changes to control blocks that maybe aren't warranted or maybe don't make sense. The other thing that is provided here is we give you the capability not only to look at the control block changes, but we give you the capability to locate all of the DBRC changes that would be warranted as a result of those control block changes. An example of this might be you're adding additional partitions to a HAL-DB database. In that case, you would have DBRC requirements, and those DBRC requirements would be generated for you. We also provide the dynamic allocation macros and do disassemblies of those as well. The generated jobs that always get generated from this process are 4 sets of JCL and 1 README file. And I said earlier, the README file is pretty much for audit purposes. It explains what this project does, it explains the components of the project, and it explains who did what when. The setup job, it actually does the backup, creates the backups of control blocks that will be changed. It actually does the gens of the control blocks and puts that information into the project libraries. The commit, 1 JCL that gets generated actually moves the control blocks into the IMS libraries, does a backup of the database so that you have a backup, a restart point in case those changes are not what you want. And it moves all of the changes into the required IMS libraries. It does not activate them though. We intentionally separated the commit 1 and commit 2 such that if there are application work that needs to be done prior to implementing in your production IMS environment, you could do that. And once that work has been done by the application area, then you can do the commit to execution, which actually activates the changes and uses Delta Plus under the covers to dynamically make those changes to the IMS environment, and makes that available then to the IMS application. And of course, the rollback job, as I said earlier, is that backout process. You made these project changes, but maybe they're not ready to be implemented yet. So you can, or you have to make changes. Go ahead and roll back to the beginning and you can start over. The other side of the product is the apps. And I explained that a little bit earlier. There's problem diagnosis apps and analysis apps. Examples of those are the DBD and PSB editor, a catalog explorer, a data explorer, a spoofy process, and also reporting, which is our database integrity reporting. An example of the way you would use that database integrity reporting would be, say for instance, you have a DBD that you're making changes to, and you're not quite sure what programs are associated with that database. Well, you could run a database integrity report that does a comparison between that DBD and its associated PSBs, and then you would have a complete list of those programs that would also may have to be included in the project for change. On the for tuning application, it's the buffer pool editor, and this allows you to make any changes to your IMS buffers as maybe your hit ratios are not where you want them to be and you need to add additional buffers to a particular IMS buffer. You can do so through the buffer pool editor dynamically. From an implementation perspective, we've provided the ability for IMS command processor, and we've provided an IMS online object deploy, which is a standalone process that's done through JCL. And then also we provide implementation tools. And the implementation tools at this time is a DBD gen process, a PSB gen process, and also an ACB gen process that includes a catalog populate. And then the final tool that's there is a catalog purge process. BMC AMI Change Manager for IMS is targeted to make less experienced universal DBAs more effective. It assists experienced IMS DBAs with implementation of the IMS catalog, and it reduces the risk of making incorrect changes to your IMS environment. It is in our BMC Automated Mainframe Intelligence strategy in the data component. All of our IMS products have been renamed over the last year, and they are all in this AMI strategy that is a BMC strategy moving forward with our products. My contact information is here. If you have any questions or comments concerning BMC AMI Change Manager for IMS TM or BMC AMI Change Manager for IMS, please don't hesitate to reach out to me. That concludes this webinar. Thank you very much.